In this lesson, we're going to discuss how we can analyze graphs by looking at key features. The first key feature we're going to look at are intercepts. Intercepts are where the graph crosses the x or the y axis. So here we have two different graphs. The graph on the left is a quadratic, so it's an x squared function. If we look at it, we can see that it's crossing the x-axis at this point here in red, and also at this point here in red. When we're writing our x-intercepts, we want to make sure that we have the x value and the y value written as a point. The y value of any x-intercept will always be 0 since it hasn't moved at all on the y-axis. So if we look at, let's say, this one on the left, we can see that the x value is -1 and the y value is 0. So our first x-intercept is -1, 0. I have another x-intercept, and that one occurs at 4, 0. For the y-intercept, we're looking to see where the graph crosses the y-axis. So right here, we can see it's crossing the y-axis. For a y-intercept, the x value will be 0 since it's not moving anywhere on the x-axis. And then the y value will be wherever it's crossing. So in this case, it's crossing at -4 for y. So our point for the y-intercept will be 0, -4. Okay, looking at the second graph, here we have a cubic, so that's an x to the third graph. And again, we're looking for our intercepts. So the x-intercepts are going to be crossing the x-axis. So we can see that there's one right here, and right here. Okay, so there can be one x-intercept or there can be multiple x-intercepts. So we can see that it's crossing here at -2 for x. So we're going to have -2, 0. It's also crossing at 1, so 1, 0. And it's also crossing at 3, so 3, 0. For the y-intercept, we're going to see where that's crossing, and that is crossing right about here. So the x value is going to be 0 here, and the y value is going to be the value that it's crossing the y-axis at. So in this case, we're going to have 0, 3. Okay, and let's notice that the x-intercept, you can have multiple x-intercepts. So you could have 1, you could have 2, you could have 3, you could have none. For the y-intercept, you will only ever have 1. So we just want to make note of that. Another key feature that we have are the extrema. So extrema are the high or low points where the graph changes from increasing to decreasing and vice versa. Okay, there are two types of extrema. There are maximum and minimum. Maximums are our highest points, and that's where the graph goes from increasing to decreasing. And minimums are our lowest points, and they go from decreasing to increasing. So if we look at this graph again on the left, we can see that the graph is going down first, so it's decreasing, and then it changes to increasing. So right here, we have a minimum value. All right, so here's a minimum. This graph does not have a maximum value because it continues infinitely upwards and doesn't have a stopping point. So for our minimum, we would just name that point. So that's the point to about -7 for our minimum. On the next graph, we have this point here, right? That is going to be a maximum because our graph is increasing and then it becomes decreasing. So at that point, we have a maximum. And that maximum is going to occur at -2 and 4. And we also have a minimum here. The graph is going from decreasing to increasing here. So we have a minimum. And this minimum occurs at the point to -2. So sometimes they might ask you for the minimum or the maximum value. If they ask for the value, that's referring to the y value, since the minimum or maximum really has to do with the y values, right? The minimum is the lowest point on the graph. And in terms of the height of the graph, we always look at the y values. So if we wanted the minimum value for the first graph, we would say the minimum value is at -7. For the second graph, we would say the maximum value is at 4. And the minimum value is at -2. Okay, here's looking at a couple of other graphs, looking for mins and maxes. Okay, so if I want to find my maximums, I can see I have a maximum here, and I have a maximum here. So that would be at the point -2, 0. And if you notice, this maximum, actually that's -1, 0. Sorry. So if I look at this maximum, This is also my x-intercept. So if I wanted to find my x-intercept here, it's crossing the x-axis at the maximum, which can happen. So sometimes your maximum, your minimum, your intercepts, they might end up being the same points, which is totally fine. Okay, we do have another maximum here, and I'm going to say that that's at about 1.5, 1.5. For our minimum, we have a minimum about here, and I'm going to say that that's about 1 and negative 2.25. Okay, it'll be easier to see when you have an actual graph. I'm just kind of estimating these, but it'll be easier to count the actual point. We'll be doing a lot with the graphing calculator, and the calculator will tell us what the points are also. So don't worry about right now if you can't see specifically what points these are. For the next graph, we have, again, 2 maximums. So our first maximum we'll say is at, I think that's 0, 3. And then our next maximum is at about 3, 7. And then we have 2 minimums. So we have a minimum right here in blue and right here. So we have a minimum at about negative 2, negative 10, and at 2, negative 1. Another key feature that we have is the end behavior. So the end behavior is very important, and that's what the graph is doing at the right and left sides as x approaches infinity or negative infinity. So when we look at a graph, the graph has 2 ends. There's a left end and there's a right end. So we want to look at each end and we want to see what is happening to the y values as x is either increasing or decreasing. Okay, so first let's just look at this. So I'm going to just draw in some arrows here. So this graph is my quadratic. Okay, it's y equals x squared type graph. If I look at the left end, okay, so we have to do end behavior for each end. So if I'm focusing on this left end, I can see that my arrow is pointing up, so it's infinitely going up and also to the left. So if this continued forever, it's going to touch everything to the left and everything up. So our end behavior, so I'm going to just write left here so we know we're talking about the left end. The way we write the end behavior is we say x is approaching what as y is approaching what. So x is approaching. If you keep going left, you're getting more and more negative. So x is approaching negative infinity. And that's what's happening over here. So even though it's pointing up and you might think that that's positive infinity, we want to think about the x's, right? It's going up and left. So the x's are approaching negative infinity. As that's happening, what are the y values doing? Well, the y values are approaching positive infinity because the graph is also going up. So it's going left and up, which is going to be negative in the x direction and positive in the y direction. Okay, we're going to do the same thing for the other end, so the right end. So if it's going up and to the right on this end, the x values are getting more and more positive as you go to the right. So x would be approaching positive infinity. As that's happening, it's also going up, so the y values are also approaching positive infinity. Now I know that this can be a little bit confusing sometimes and knowing what to use and what to put where. The main idea here is that you're always going to be using infinity, whether it's positive or negative. A good way to kind of think about this is about using the coordinate plane. So I'm just going to draw a little coordinate plane down here. So if I have a coordinate plane, we have the different quadrants. Right, so in the first quadrant, which is over here, think about what your x's and your y's are. So in this quadrant, my x's are positive and my y's are also positive. In the second quadrant, my x's are negative and my y's are positive. Right, so just think about picking a point in the quadrant. If I'm in this third quadrant, my x's are going to be negative and my y's will be negative. And in this fourth quadrant, my x's are going to be positive and my y's are going to be negative. Now, if you know the quadrants and you know what signs x and y are going to be, it will make end behavior a lot easier. So when I compare the quadrants to my graph that I have, I can see that my left side, right, the left arrow, that is in quadrant 2. So that will correspond to the signs that we have in quadrant 2. So x is negative, here's negative, y is positive, positive. Okay, the only difference is that we have to make sure we have infinity in that. The right end is in the first quadrant. So x should be positive and y should be positive. Okay, so let's keep this idea of this knowing the quadrants, and let's look at another one. Okay, so here again we have some graph. I'm going to just draw in my arrow so we understand that this extends. So again, we need both of our ends. So for the left end, if we look at this, again, you can think about it as what is x doing and what is y doing, or you can simply just think about what quadrant we're in, right? So over here, we're in the third quadrant. In the third quadrant, x's are negative and y's are negative. So we can say as x approaches negative infinity, y approaches negative infinity. Okay, so as x gets more and more negative, y also gets more and more negative. So it's going left and down, both in the negative direction. On the right end, okay, we're in the first quadrant. In the first quadrant, x and y are both positive. So x is going to approach positive infinity, and y is going to approach positive infinity. So as x gets more positive, y gets more positive. Okay, let's try another one. Again, I'm going to draw in these arrows. So we have the left end. Here in this left end, again, we're in that third quadrant. X is negative and y is negative. So x approaches negative infinity as y approaches negative infinity. And on the right end, we're in the fourth quadrant. In the fourth quadrant, x is going to be positive, y is going to be negative. So x approaches positive infinity as y approaches negative infinity. So as x gets more and more positive as it keeps going to the right, the y's are going to get more and more negative as it's going down. Okay, let's look at one more. Again, I'm going to draw my arrows in. Okay, so the shape of the graph doesn't really matter. All we're focusing on are the ends, right? So where we drew those arrows. So again, we have to do both ends. So we look at the left. Okay, here we're in the second quadrant. So as x approaches negative infinity, y approaches positive infinity. On the right end over here, we're in the fourth quadrant. So as x approaches positive infinity, y approaches negative infinity. Okay. The last concept that we're going to talk about are increasing and decreasing intervals. Okay, so this is where the graph is going up or down as x increases. Okay, so from looking at a graph, we can see where it's increasing and decreasing based on is the line going up or is it going down. When we write intervals, we're going to write them in terms of the x values. So we're looking at the graphs from left to right, and we're looking at the x's and what values between them they are. So for instance, let's look at this example. Okay, so if I look at this first piece, I'm going to try to trace it poorly, sorry. So this first piece is going up. As I start drawing it from the left, it's increasing until you get to this maximum value, right? The maximum value is going to be where it stops. So what I'm going to do is I'm going to label my maximums and my minimums because those are also called turning points. So when you change from increasing to decreasing, you have a turning point and it ends up being your maximum or minimum. So I'm just going to write here that this is the point -2, 4. And I'm also going to label this piece here, this point, so 2, -2. Now, if you notice here, it says as x increases. So we're really focusing on the x values. So as I start, I also want to take into account my end behavior. So I'm going to do the end behavior for this. So for my left end, it's in that third quadrant. So x is going to be negative infinity, and y is going to be negative infinity. And on my right end, x is going to be positive infinity, and y is positive infinity. Okay, so it's always helpful to have the end behavior written out as well as the maximums and the minimums, so that way we can figure out the x values that we're increasing and decreasing on. So as I go from left to right, my graph is increasing from my end behavior x value to my maximum x value. So from negative infinity, which is all the way left, all the way until we get to -2, my graph will be increasing. So that would be the interval negative infinity to -2. Okay, at -2, my x value is at -2, my graph, I can't really trace it, oops, very well, but my graph is decreasing. We'll pretend that that looks good. Ooh, not good, but pretend. Okay, this piece, that's terrible. But that green piece, that's not very good. That is going down, right? It's decreasing. My curve is being drawn down. And the x values that is between is -2 to 2. Right? So from x equals -2 to x equals 2, that piece of the graph is going down. So that's decreasing. So from -2 to 2. And then, let's see if I can draw this anywhere good at all. Okay, this purple piece, oops, that is increasing. So again, from left to right, after I get to that point to -2, my graph is going to turn and it's going to increase. So it's going to increase from my x value of 2 all the way to infinity. So it's increasing from 2 to infinity. So I have my increasing intervals and I have my decreasing intervals. Now, if you notice, it leaves off on one and picks up on the other. So for instance, I increased from -infinity to -2. That -2 I picked up in the decreasing and it went from -2 to 2. And then I left off at that 2 and I picked it back up when I increased again from 2 to infinity. Okay, so from left to right, we're looking at strictly the x values. Okay, so let's look at one more of these. Okay, so again, the way I'm going to set this up is I'm going to put in my end behaviors and my maxes and mins, so I have all my x values that I need. So here, x is -infinity and y is +infinity for that left side. For my right side, x is going to go to +infinity and y is going to approach -infinity. I have a minimum here, and that is -2, -10. I have a maximum here at 0, 3. I have a minimum here. We'll just say that that's 2, -1. And then we have a maximum here. I'm just estimating because this graph is not super precise. I'll say that's 3, 7. Okay, right now that's not the most important, but so notice that I'm ignoring the x-intercepts and the y-intercept. In this case, the y-intercept is the maximum, which is fine, but I'm just looking to see from my end behavior to my turning points or my maxes and mins, what's happening to my graph. So again, we're going to start from the left. Always start from the left. The first piece of my graph, ooh, it's really bad, goes down. It's decreasing. Let me erase that so you don't get confused. But the first piece of my graph is decreasing. So we're decreasing from this x value to this x value. So it's decreasing from -infinity to -2. Okay, that's the x values. At -2, it turns around and then it starts to increase. So we increase from -2, where we left off, to the next turning point, and we look at the x value to 0. Then we decrease, and it decreases from 0, where we left off, to the next x value of the turning point, which is 2. Then we increase from 2 to the next x value, which is 3. And then lastly, we decrease, a little comma here, we decrease from 3 to the end behavior x value, which is infinity. Okay, so there could be a lot of different intervals from increasing and decreasing depending on how many turns your graph has. But the main idea with increasing, decreasing is that you want to focus on the x values only from the end behavior and the maximum and minimums. And you want to go from left to right on the graph. So just follow the curves of the graph.